Okay. Hi, everyone. I just want to say thanks for choosing to come to the session. There's quite a lot of people here, so it's really exciting to see. So today we're going to be learning about how to get started monitoring your applications and your services using Prometheus. So a little bit about me. So my name's Bridget. I'm a software engineer based in Bristol in the UK, and I work with the lovely folks at Bitnami, where, as Zara said, working on tools to help developers migrate their applications to the cloud. So today we'll be covering, we'll be taking a look at what monitoring is, why it's a useful practice, and then we'll get started on looking at what Prometheus is. So we'll look at some of the concepts behind it and some of its features. And then we'll get started with a demo so you can see how to actually get started and use it. Sorry. Is it working?
No, volume up.
Oh, volume up. Okay, so can everybody hear me okay? Yeah? No? More? I'll try and talk a bit louder. It's closer to my mouth. There we go. Yeah. Okay, I'm hearing myself a lot more now. Okay. Yeah, so then finally, once we take a look at Prometheus, we're going to do a demo so you can actually see how to get started with it. But before we actually get into the details of what monitoring is, I thought it would be useful for me to share a little bit about my development experience that has led me to needing to know about monitoring. So I've been a developer for about 7 years now, and I've spent the majority of that time working on development tools, so making software for other software developers. So I've worked on things like tool chains and internal tools for testing, and a lot of the tools I worked on, they kind of look something like this. So they were small processes that took some inputs and did some processing and then produced some outputs, and then the processes exited. So all of these tools, they were typically a single process that were short-lived, and they ran on a single machine, so typically a developer's machine. So and they had very clearly defined inputs and outputs, which meant that they were easy to test. And because they ran locally on developers' machines, it was easy to reproduce environments. If, for example, we had bug reports or something, we could ask the users about their environment, and then it made it easier for us to diagnose the problems. But about a year ago, that all changed for me. I joined a new team at Bitnami working on a software as a service product. And if I were to draw, this is my attempt at sketching kind of an architecture diagram, it would be something more like this. So the product that we work on is a microservices architecture, and it's deployed on Kubernetes. And so with this, I had a host of challenges that I hadn't had to face before as a developer. So the first thing, given that it's a SaaS product, it's a web service. With these, these are all long-running processes. And with long-running processes, I have to think now about, they have to keep running. So I have to consider things like the resource usage, and what if the CPU consumption increases or the memory consumption increases over time? And if we hit those limits, chances are we're going to hit bottlenecks and our system will slow down and it will be an issue for our users. And then we also have to make sure that they continue to run. It's like websites aren't much use if they stop working after an hour or a day. And also having multiple services means that we need to consider the network interactions between these services. And given as well, we were running on Kubernetes. This is a shared cluster that other teams within the company could be using. So we couldn't always reason about the state of the system whenever it's actually deployed. And then finally, I mentioned that we were using CI/CD. So we wanted to, it was a new product, so we wanted to iterate quickly and release changes as soon as they're ready. So whenever we're working with complex systems like this, it can be tempting to to try and add more tests. But given that there are so many unknowns about the environment that we're deploying into, and also the fact that it's a system that's changing state over time, then we can't catch all of the potential issues that that our users might run into. But thankfully, we're not destined to have buggy software, and this is when my colleagues introduced me to the concept of monitoring. So monitoring is the use of additional tools and services to collect, process, and aggregate data about our live running systems so that we can gain insights and get a sense of how they're actually performing whenever they're deployed. So there are a number of reasons why we should monitor our systems. The first is that it allows us to analyze long-term trends. So we can answer questions about our systems like, are we gaining more users, and how frequently? How quickly is our database growing? And we can also use monitoring to answer questions, to understand the impact of changes that we make to our systems. So perhaps we have some hypothesis that we make a change and it's going to improve the performance. We can actually deploy that change, and because we're gathering data about it, we can see whether that has been proved true. Because we have so much data, whenever we're collecting and gathering all these metrics, we can visualize this. So we can create dashboards and graphs so that we can see at a glance the state of our system. And that can help us easily spot patterns and trends and view things like resource usage and so on. But we shouldn't rely on having humans monitor and watch graphs to see if things are going wrong. So this is when we can introduce alerting. And alerting can let us know if something is broken or is about to break so that we can actually act on it and improve it and fix the issue before our users actually encounter it. And then finally, it can help us perform analysis and debug our systems. So if there had been an issue with a particular service, because we have things like a dashboard and all the metrics there, we can look at other services at the same point in time whenever we encountered an issue to see, was there something in particular that caused it and what else happened around that time. So when we're monitoring, it's important to consider and decide what it is we're actually going to measure and what data we're going to collect. So as someone who's fairly new to this, I've been doing a lot of learning in this area, and I've got a list of 4 key signals that you should use to understand the state of your system. And I've really just taken this from the Google SRE book because it's been really useful for me as a beginner in this area. So the first signal that they recommend is tracking or assessing the latency of your application. So how much time is it taking to service requests that come in? The second is traffic, which is measuring the load that is currently being placed on your system. So it could be how many HTTP requests are you currently serving, what's the query rate to your databases, and so on. So you can adapt this to focus on metrics which are appropriate for your system. And it's also good to know how many errors your system has currently experienced. So whether that's you start serving 500 requests from your HTTP services or other error conditions that you've put in place. And then the final one is saturation, and that's a measure of how full your system is. So whenever we talk about saturation, it's thinking about things like the resources that your services are consuming. So thinking about things like memory usage or CPU usage and so on, because it's very likely that whenever you hit those limits, the performance of your system will be severely impacted, and that will cause a problem for your users. So looking at trends and having alerts in place, we can see when we're going to hit those limits, and then we can act to respond before it actually becomes a problem. Of course, there are other things that you can measure, but if you're new to this practice, these four metrics or these 4 signals are a good place to start. And just like a follow-up, If you don't know about the Google SRE book, I find it really useful, so definitely check it out. It's just available online for free. Okay, so now that we've talked a little bit about what monitoring is and why it's useful, let's take a look at how you can actually get started monitoring with Prometheus. So Prometheus is an open source systems monitoring and alerting system. It was founded by the folks at SoundCloud, sorry, it's slipping, and is part of the CNCF, so the Cloud Native Computing Foundation, and was actually the second project to join after Kubernetes. Prometheus works by pulling metrics from a set of configured targets. So each target exposes an HTTP endpoint with the metrics, and then Prometheus will go through all of the targets that it knows about and pull the metrics from those services. The data model that Prometheus uses is described as multidimensional. So Prometheus collects time series data, and each data point can be uniquely identified by using a metric name and a set of labels, which are key value pairs. But we'll go into the data model in a bit more depth shortly. It also provides its own query language, PromQL, for selecting and aggregating data so that you can gain more insights into the data that you've collected. Although you can configure services manually, or configure the targets manually for Prometheus Discrete, it actually supports service discovery. So depending on the different deployment options that you're using, there are integrations there so that you can get it to scale and find services that you maybe haven't statically configured. So for example, if you're running on Kubernetes and you scale up a service to have to use more instances of a particular service, then it can automatically find those and start scraping those metrics from those endpoints. And the final concept around Prometheus is that it's a white box monitoring approach. So this means that you can inspect the internals of the system, so the services that are being monitored report their internal state. So it's not, so it's different from, it's not just how it responds from an external point of view, it's the services themselves reporting their state. So this is like an overview of the architecture for Prometheus. So let's look at how it gathers all the data. So in the center, we have the Prometheus server, and that is responsible for retrieving the metrics from the list of configured targets. It also stores those metrics and then also performs the PromQL queries. So it retrieves metrics from the jobs and exporters. So these are the services which are exporting data. But in the case where you have short-lived jobs, so maybe jobs which you start and they don't last for very long, Prometheus also provides a push gateway. So instead of needing, so rather than missing out on those services, which are those jobs which might start up and stop between metric scrapes, they can push their metrics to the gateway, and then Prometheus will pull those metrics instead from there. So I mentioned there's also the service discovery component, and that takes care of finding different targets to scrape from. You can have different consumers of the Prometheus data, so you can use the web UI itself to inspect the data and see some graphs. But another popular tool that's quite often used with Prometheus is Grafana. So that allows you to create dashboards for your data. And finally, Prometheus can be configured with alerting rules. So whenever a particular alert is triggered, it sends its alerts to the alert manager. So this is a separate service, and it can perform operations such as deduplication and grouping of alerts. And then you can configure it to send alerts to a particular receiver. So whether you want you want to get pages for some alerts, but maybe you want other ones to be reported to Slack, that can all be configured within the alert manager. So let's take a deeper look at the data model that Prometheus uses. So as I said earlier, Prometheus collects time series data. So for each time series, there's a metric identifier, and then a series of samples, and where each sample is the value which was recorded, or the value which was observed, and also a timestamp of when that value was recorded. And a metric identifier consists of a metric name followed by a set of labels, which are key value pairs. And it's the labels that make the data model multidimensional. So different combinations of labels can be provided for the same metric so that you can produce unique time series. So for example, here we have a metric, which is the total number of HTTP requests. And we provided different combinations of labels, and these are unique time series. So we can gather the number of requests, the post requests to a particular endpoint, and also the get requests to that endpoint. So there are 4 metric types which Prometheus offers. The first is a counter, and this is a single numerical value which can only ever increase. So you might use it, for example, counting the number of requests or the number of errors within a system. The second metric type is a gauge, and this is also a numerical value, but the difference from a counter is that it can also go up and down. So perhaps you might use this for particular system metrics, such as the memory usage, and things like that. Then the final 2 metric types are more complex, as these are histograms and summaries. So these metric types both sample observations and are commonly used for things like request duration or response sizes. So you can use both of these metric types to calculate percentiles or quantiles. So, but the difference in these 2 metric types is how those values are actually calculated. So histograms are configured with buckets, and when an observation takes place, the value is placed into the appropriate bucket. But for summaries, they calculate their quantiles on the client and then export those directly. And there are trade-offs to both of these approaches. They both allow you to answer or to understand similar properties about your service, but there are things to take into consideration. So I think if you were going to look into using Prometheus more, they provide documentation to help you understand the 2 trade-offs between these 2 metric types, so you can choose the one that best suits your needs. To export metrics from a service, I mentioned that they're gathered over HTTP. So you just need to provide an endpoint that provides the metrics in a particular format. So each metric, so typically the endpoint is /metrics, but that can be configured to use different ones if needs be. So this is the format that the metrics are provided in by your service. So you provide the name of the metric with the help and a type annotation. So the help text is just describing, it's just for human readable format. So you can say, this is my metric, the total number of requests, and it's the type counter. And then following that, you have the time series for each metric, for each, you have the time series for each combination of labels, and then also the value which has been recorded at that time. There are a number of client libraries available depending on which programming languages you use. So some of them are official libraries provided by the Prometheus project, but others are third-party. But there's a lot of them available, so it's probably one depending on the particular languages that you're using. And then finally, there are also exporters for existing services that you might be using. So perhaps you've got databases or message queues. There are also exporters that you can use for those to export metrics about those services as well. Okay. So now that we've gone through the basics of Prometheus, what I was going to do is walk through a demo showing you how you can configure it and get started, and then gather some metrics about an application. So the code for this demo is available on GitHub, and I've tried to write it in such a way that it can all be run locally. I'm running it locally, and I've included instructions and so on in the README, so if you want to try it out, please check out the project. So this project that we'll be adapting is an existing Nodejs Express API. So we're going to take that existing code and then instrument it using a client library, and then we'll look at like how you can actually configure alerts and trigger them and so on. Okay. So I'm just going to Is it there? Great. So it just makes it a bit easier for me to demo this. So I've got, I think what gets used for a lot of demos is a to-do list application. So this is a really quite simple REST API with an Angular front end. So we can write some to-do things, to-do items, and then tick them off. But so if we want to actually monitor this, the first thing that we need to do is actually get Prometheus up and running. I don't know where my terminal's gone. Okay. So I have just a virtual machine set up with Prometheus and Alert Manager already downloaded and installed. I've got a configuration file available. So what I'm going to do first is just start these two services, and then we'll take a look at how they were actually configured. So this is, sorry, can I just check, can everyone see that? Should I make it a bit bigger or anything? Or is it okay? Okay, brilliant, thank you. Sorry, I should have checked that. So this is just a really quite a simple configuration for Prometheus. So we've got a global config, which is saying that we want to scrape each of our targets every 15 seconds. I've got a file for an alerting rule, but I'll come back to that later. I've just configured it all up front in advance, and then we'll go through it. I've also configured Prometheus to say where to find the Alert Manager service. So that's running on the same machine on port 9093. And then finally, I've got some static configurations for the services and where to find them so that they can be scraped. So as I mentioned before, with service discovery, this is where you could use service discovery, but for the purposes of this demo, to make it a bit easier, I'm just going to configure them manually. So the first job that we have is Prometheus. So Prometheus actually exports its own metrics, so you can use Prometheus to monitor itself. So that's just a static config, and I've said that it's running at this URL. And then the second job is to enable the scraping of the to-do app that we have, and so that's the URL that's being used for it. So now, hopefully, I've started those two services. So here we have the Alert Manager running and Prometheus. So this is the Prometheus UI. It's pretty simple. So this is the homepage for it. So whenever you go to this URL, or whenever you go to Prometheus, you get presented with a text box, which is where you can input PromQL queries. And then you've also got a drop-down which shows you all the different metric names that your current Prometheus instance knows about. So let's look at the two targets that we configured. So in our configuration, we had those two targets. So we had the Prometheus itself, and its state is now up because it's exporting metrics, and those are now being successfully scraped by Prometheus. But we configured our to-do API, but that is failing because we haven't actually configured our API to actually report with metrics. So So the way that I've structured this demo is that I've got all of these changes already in branches, and I've got some images built. So I'm using Helm to deploy this. That's not really relevant specifically for the demo. It's more just it's easy for me to get the new changes in place. So what I've just done is I've checked out a new branch which has some changes in place, which is going to modify our code to collect and export metrics. So this was the code that we had before. So like I said, it's just just an Express API. So here we have some endpoints where you can get all the to-do items. You can create a new one or delete an existing one. But in this branch, the first change that I've made is to introduce the Prometheus client for Nodejs. So we can configure an instance of the client and then also instruct it to start collecting default metrics about the system. And so what this client is doing is it's just reporting information about Node.js itself. So not anything about our application, just Node.js in general. So once we have that in place, the next thing is to actually provide an endpoint for those metrics to be exported. So here I've added the metrics endpoint. So whenever a request is made to this, we can just send the response with all of the metrics that the client currently knows about. So I've deployed that change already. So now if we refresh this, we can now see that it's now successfully gathering metrics about our API because this endpoint is now available. So this is the format that we saw earlier. So this is what it looks like for the Node.js metrics. So now if we go back here, we can actually see the Node.js metrics in there, and we can query those and look at those values. Okay, but just having metrics about Node.js itself isn't that useful. We want to get more information about our actual application. So in my second branch here, I have modified the code so that we can collect more application-specific metrics. Okay, so I've defined metrics of each of the different types up front, which we can use at other points in the code. So we have two counters, one for counting the number of errors that the application has encountered, the total number of to-do items which have been created. Sorry, I should just say some of these metrics are a little bit silly, but like it's just for the purposes of demo, so you can kind of see how it works. And then we've got a gauge, which is going to show the number of to-do items which are currently incomplete. So maybe they've been created, but they haven't been deleted yet. And so we can just put these to use simply by calling methods on these metrics themselves. So for example, whenever we create a new to-do item, if it is successful, we can just increment that counter. And similarly for the gauge, whenever we create a new item, we can increment it there as well. And then if we delete an item, we can decrement that, the gauge. And we don't need to make any additional changes to our metrics endpoint because all of those metrics are just going to be exported by the client anyway, so we don't need to do any additional configuration. So then the final two metrics that I've introduced are for gathering information about the request duration. So I've got a histogram and then also a summary. So both of these metrics I've added or I've configured so that we can add labels to these metrics. So whenever we look at the time series, we'll be able to see which method was used, what was the endpoint, and then also what was the code, the response code for that. So I've applied that to both the summary and the histogram. But as I mentioned before, the difference in the histograms and the summaries is the additional metrics that they so histograms are configured with buckets. So we're collecting the amount of time that it's taken to perform a request in milliseconds. So here we have some buckets of 5 milliseconds, 10 milliseconds, all the way up to 1,000. And Prometheus histograms actually provide an implicitly added bucket called the infinity bucket. So if you record a value which is outside of this range, then it goes into infinity. So whenever we sample using this metric type, so if we have a request which takes 80 milliseconds, then it's greater than 50, but still less than 100, so that's the bucket where the observation will take place. And then for the summary, we're going to calculate percentiles. So the client is going to calculate percentiles rather than exporting the sample or the sample counts directly. So we've got the 0.5 quantile, or 50th percentile, which is the median, and then we've configured these all the way up to the 99th percentile. So this will allow us to, both of these will allow us to answer questions like, how long is it taking us to serve 90% of our requests, or 99% of our requests? And then to use those two metrics, I have modified the application so that I'm just using an express middleware so that for every request, whenever it starts, we record the start time of the request, and then when it finishes, we record samples, we observe samples for the histogram and the summary based on the total time that it took to service that response. And I forgot to start something. So in order to produce metrics that we can view, I've just got a client which simulates API usage. So I'm just going to set that running so that we can actually have some metrics to actually look at for our application. Okay, so hopefully now we should have, so we've got some metrics here. So now we can see that so far we've created 32 to-do items, and you can view just the value itself, or you can get Prometheus to graph that value over time. So I'm just reducing the scope of when this graph is taking place. So this is over the last 1 minute. Here you can see that the number of to-do items is gradually increasing over time. But let's take a look at some of the other metrics that we started to gather. So both the histograms and the summaries export either the quantiles or the buckets, but then they also export the count of the different observations that took place, and then also the sum of the values that they observed. So looking at the count metric, here we can see these are all the different combinations of labels for this particular metric. So here we can see the delete method on this particular endpoint, the get on this one, and then also the observed values. But with PromQL, what we can do is we can refine the view that we have here, so we can add like restrictions. So maybe we are only interested in GET requests to our API. So what we can do is specify that label. And that filters the results so that we can see only time series which satisfy that particular label. And you can add multiples of these. So maybe you also care about the root being to-dos. So then that's kind of filtered that down. When we make a request, whenever we make a query like this and it returns a single value, that is just the most recent observed value that Prometheus has actually recorded for this particular time series. But what you can also do is provide a range of time, so you can see all the different or all the different samples which have been recorded. So we can say over the last 2 minutes, here are all the different samples that were recorded. So, as I mentioned before, time series data is the sample with the timestamp of when it was recorded, and so that's what's being displayed here. So this is the sample value, and then also the time at which that value was recorded. So PromQL provides a number of different operators and functions that you can use. So there are operators like addition and subtraction, division, and also you can do comparisons. But let's look at some of the functions and also the aggregation operators that you can use. So one function that you might want to use is you maybe want to see the rate of requests that have taken place over the last 5 minutes. So the rate function just calculates the per second average for a particular metric. So here we can see over the last 5 minutes, this particular endpoint had an average rate of just under 6 requests per second, or this one was just over 1 request per second. But you can also use aggregation operators to sum all of these, so you can get the overall rate across all the different methods and endpoints that you have. So you can sum those and get the total, which is just 11 requests per second. But the aggregation operators also provide additional clauses that you can use. So maybe you want to sum by a particular label. So let's actually take a look at what that looks like. So maybe I'm interested in the rate of requests for particular endpoints. I don't want to distinguish on the method that was used. I just want to look at the overall requests. So here we can see all the different endpoints that have been monitored for, or that we have metrics for in our service, and the overall request rates for those. Okay. So now we can take a look at how to configure alerts. So as I mentioned earlier, I've already configured. This keeps popping back up. I don't want it to. There we go. So as I said, we can configure alerts in our code. We can configure alerts in Prometheus so that whenever they are triggered, we can forward alerts to different services. So I have another change here, which is going to introduce a break in the code, or which is going to introduce an alert to be triggered. So I'm just going to deploy that while I show you what the alert is actually checking for. So here I've got an alert configured, which is going to look at, out of all the total rate of requests over the last 5 minutes, what percentage of those were 500 responses. So if that goes over if it goes over 10%, then I want an alert to be triggered, and I want to know about that. So what I've done in the code is to just introduce a really buggy change. Maybe it was something that slipped past tests, we don't know. So it's just, if we end up with more than 10 to-do items, we're just going to send a 500 response and say that there are too many, otherwise we'll respond as usual. So hopefully now we can see, if we try and actually interact with this app, we're getting error requests and it's not working for us. So now we can take a look at this this alert, and we can see that it's now in a pending state. So what that means is that error case has been encountered, but it's going to wait for a period of time before sending the alert, just in case it's like a temporary issue and it might resolve itself. So that's going to take some time. I thought it might have started firing already. Okay. So in the meantime, I'm also going to show you how I have configured the alert manager. So for the alert manager config, it's also just YAML, but I've configured a Slack receiver so that whenever an alert comes in, it's going to send that error to Slack. So now, if I go back here, okay. So this is now in a firing state, which means that for over that period of time, that error case has been true. So now it's going to start sending the alert. And here we can see we've just had a Slack alert come up to tell me that the response rate has got, or sorry, the alert has been triggered, and that we've got a high percentage of 500 responses. And then in the alert manager as well, you can view that that alert, and then there are also other things that you can do in the alert manager, such as silencing them or grouping them, and so on. So yeah, so that is it. Hopefully, that's giving you a little bit of a teaser on how to get started. And that was all I had time for. I'm kind of getting notes to finish up. So thank you very much.